Hello and welcome to Big Science, and here, topic of the week, doesn't get much bigger than black holes. Very much in the press at the moment. Let's think of some 3 questions about black holes. Now there's many questions we could actually ask about black holes, but in this short video I just want to talk about 3. First of all, what is a black hole? Will our sun ever become a black hole? And how on earth did scientists photograph the black hole? Well, let's start off with the first question. What is a black hole? Well, a black hole is formed at the end of a star's life sequence. I'll explain this in just a moment. Okay, but it's the end point of a star's life sequence. Now, a black hole is an object that's got such a massive force of gravity that nothing can escape, not even light, hence the blackness. The black hole's mass is concentrated at a point of almost infinite density called a singularity. At the singularity itself, now this is the weird thing, gravity is almost infinitely strong, so it crushes normal space and time out of existence. Wow! What that means is, at the singularity, at the core of the black hole, the basic laws of physics, time and space, no longer exist. This is very hard to get your head around, but that's what happens. Right, second question. Will our sun become a black hole? Well, the thing we've got to realise here is that stars follow a specific sequence, but it depends on the size of the star. So in the beginning, we've got this cloud of gas. That cloud of gas is where stars are born. Now, all stars become a protostar, and then they become what we call a main sequence star. But those stars can differ in size. Now, some stars are about the same size as our sun, and some stars are much bigger than our sun. So what happens to them? Well, let's first look at those that are about the same size as our sun. Okay, they go through the main sequence like our sun is now. Our sun at the moment is going through a main sequence stage. Okay, get lots of light. And eventually, it will become a red giant. And after it becomes a red giant, it starts to shrink and becomes a white dwarf. And eventually, our sun will become a black dwarf. This is many, many billions of years in the future. There's nothing to worry about at the moment, but that's what we think, that's what scientists think will happen to our sun. Now, for stars are much bigger than the sun, there's a different pathway. And this is it. They become, first of all, having passed through the normal main sequence, they become a red supergiant. Okay, supergiant. Then they become a supernova. This is a massive explosion in space. This is followed by the formation of a neutron star, and then we get the black hole. Now it says here, if the star is massive enough, it becomes a black hole. Not even light can escape from this super dense point in space. So a black hole is formed as a result of this pathway through stellar evolution. Okay, so stars much bigger than the sun could eventually become a black hole. Next question, everybody asks this one, how on earth do we photograph the black hole? So what we've got here is not an actual photograph you might take with your camera out the window. This has been put together from radio signals. So what happened was that astronomers on Earth linked together 8 really powerful telescopes, and these were dotted all over the planet. And what they then did, it took about over 200 researchers, they stitched together all the data from the 8 radio telescopes around the Earth, and what that did, it created one giant telescope from which the image could be produced. So that's how they managed to take the photograph. It took 2 years to actually get the photograph as we see it here. So I hope we've answered some questions there about black holes. What is a black hole? We know. Will our sun become a black hole? Well, ours won't, you know. And how do we photograph a black hole? A lot of time and effort on behalf of scientists. There's many more questions we could have asked about black stars. Let's just give an introduction. So thanks for joining me for this video. This video has been brought to you by Science Video Courses. Please visit us at www.sciencevideocourses.com. I'm Graham Bray, and thanks for your attention. Bye-bye for now.